This conference will now be recorded.
Good morning, students. In today's class, we are going to discuss about different types of induction motors and what is the importance of slip in induction motor. So these are the two topics we are going to be discussed in today's class. See, already we've seen, right, different types of AC motors, different types of motors based on the supply and based on the structure, based on the applications, and based on the different criteria. So we discussed in a previous class. Now, in this class, we are going to discuss about how many types of induction motor and what is the difference between DC motors and AC motors, and how what are the parameters are influencing the induction motor. See, generally in domestic, that is in domestic area, we are getting that AC supply, right? So for AC supply, for the motor should be run by the AC supply, we can call it as an induction motor. So if it is single phase means single phase induction motor, and three phase means three phase induction motor. So out of these two, which one is self starting and which one is not self starting? So we have two types, right? Single phase induction motor and three phase induction motor. Among these two, which one is self starting and which one is not self starting?
Sir, single phase, sir.
Single phase is what? Self starting or not self starting? Right. See, based on the supply, we have the two types, right? One is AC supply, and another one is another single phase induction motor, and next thing is three phase induction motor. Now, out of these two, we need to find which one is self starting and which one is not self starting. Here, the single phase induction motor not self starting, because there are certain regions I will explain later. And three phase induction motor we can call as self starting induction motor. Right now, how we can make that single phase induction motor as a self starting? So single phase induction motor manam ela self start ante it has some four criteria. So what are the criteria means, generally where we can see the single phase induction motor? Single phase induction motor ekkada use chestaru? What are the different types of applications? So tell me one example for single phase induction motor. Right. See, for single phase induction motor, one of the example is the motor which is using in the ceiling fans. If you observe the ceiling fans, it is connected to the one capacitor, that is condenser. So without capacitor, the fan should not be run properly. So for that, we need to be connect the capacitor to the fan, then only it will rotating continuously. So that's why. So this is categorized by the starting methods. So based on this method, the single phase induction motor is classified into four types. What are the four types means? The first one is capacitor start, capacitor run induction motor, and second one is capacitor start induction motor. Third one is split phase induction motor, and fourth one is saddle port induction motor. Now, out of these four, our ceiling fan motor is belongs to which type? So we have the four types, right? Capacitor start, capacitor run, induction motor. Second one is capacitor start induction motor, shaded pole induction motor, split-ring induction motor. Among these four, our ceiling fan having a which type of motor?
Capacitor start, capacitor run, sir.
Capacitor start, capacitor run, induction motor. Now, these are the four methods we can make that single phase induction motor as a self starting. So general ga single phase induction motor అనేది not self starting కాదు. So దాన్ని self starting చేయాలంటే we need to follow these four methods. Out of these four, we can achieve that single phase induction motor as a self starting. Now we will see that where three phase induction motor we are using. Generally, our load side we have two types of supply. One is single phase supply and three phase supply. Now, what are the why we need to use these two means if the load is high. So if the sum of the loads needs above the 230 volts. So at that time we can get that three phase supply. What is the voltage of three phase voltage? What is the voltage value?
400 volts.
Right, 400 volts. Do you know that how you got this value? 400 volts ఎలా వచ్చింది? So how means the three phase voltage is equals to √3 times of single phase voltage. If you multiply this √3 into 230, then you will get the 400 volts. √3 into 230. So this is the value we can get for the three phase voltage. Now generally the three phase induction motor we are using in companies, industries, agriculture areas where it needs heavy load. So where the load is high, at that area we can use that three phase induction motor, and it has different types of advantages. Let me discuss. The first one is it is simple in design. See, because if you seen that DC motor, it has the stator and rotor, right? In rotor we are going to be place the armature conductors in slots. So it is very complicated because we have to place the armature conductors at a particular slot. If there is any mismatch in that, then the DC motor should not be working properly. So that's why but in the case of induction motor, we this type of difficulties we can't able to face. So that's why it is simple in design and inexpensive. So it is easy, it is less in cost when compared to the DC motors. High power to weight ratio and easy to maintain. Direct connection to AC power source. So we are directly connected to this three phase supply. So there is no need to use in between that any component here. So these are the 5 major advantages have by that three phase induction motor. Next, so let me see that what are the parts having that AC motor. So here AC that is a AC motor is belongs to single phase and three phase, but well construction point of view both are same, like stator and rotor, bearings, cooling fan, yoke. So these are same. The only difference is rotor side. So what type of rotor we are using, that should be decide whether it is single phase induction motor or three phase induction motor. So these are the common parts we can observe in DC motor as well as AC motor, that is stator, rotor, bearings, frame, that is yoke, cooling fan, that is and so that is a bearings housing. Now already you know that what type of material we are using the stator. ఏ మెటీరియల్ యూజ్ చేస్తారండి? What type of material we can use for stator construction? Silicon steel or cast iron?
Silicon steel, sir.
So silicon steel we can use, but small ratings, that is small size device, we can use that cast iron. Why? Because when compared to the steel, iron has a more weight. Suppose if we are using this material for large scale machine, its weight will be more. So that's why for large scale machines they are using silicon steel. For small scale device they are using cast iron. Now already you know that bearing purpose. So it is used to frictionless operation, and the frame it will provide that protection for the internal parts and mechanical support to the internal system. And these are the basic parts we can observe in the AC motor as well as DC motor. Right. Now see that three major points of the three-phase induction motor. The first one is an induction motor is works on the transforming action. So I already told you that the three-phase induction motor should be work. It is similar to the transformer. The only difference is, so how we can compare means, suppose in transformer if it is primary, in induction motor it is stator, and it is secondary in induction motor it is a rotor. So but the working principle is very similar to this transformer and induction motor. That's why the three induction motors should be comparing with the transformer. And it is also called as asynchronous motor. So are you heard about synchronous and asynchronous word? Synchronous and asynchronous అనేది word ఏంది? What is the meaning of synchronous and asynchronous? See, if you know means tell me, otherwise I will tell you. No problem. Right. So I will tell you that. So this is the stator of the three-phase induction motor, and it is the rotor. Right. Now, when we are applying the three-phase supply to the rotor, that is due to this excitation, an RMF is produced, that is rotating magnetic field. So keep remember this abbreviation. RMF is rotating magnetic field, and it is rotating in between that gap, that is stator and rotor gap undi kada, aa gap is rotate avuta untundi. And this speed of this RMF we can represent in terms of synchronous speed. So the speed of the rotating magnetic field is rotating at synchronous speed. Due to the synchronous speed, the rotor will be rotated, but this rotor should not be rotated at synchronous speed. It is always less than the synchronous speed, and it is denoted by NR. So here NS is a synchronous speed, and it is mentioned for that RMF, and NR is the rotor speed, and it is mentioned for the rotor. In case of induction motor, the rotor should not be rotated at synchronous speed, is always rotating at N, that is rotor speed. That's why the three-phase induction motor we can call as asynchronous motor. If the motor should be running, it is equal to the NS, that is ante rotor kuda synchronous speed rotate aithe danni synchronous speed antar, synchronous motor antar. Kaani ikkada rotor anedi manaku synchronous speed kanna takkuva rotate avutundi. That's why this is called as asynchronous motor. How we can calculate that synchronous speed? So ఎలా క్యాలిక్యులేట్ చేస్తారు అంటే ఈ రొటేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్ అనేది ఇంత స్పీడ్ లో రొటేట్ అవుతుంది అని హౌ వీ కెన్ క్యాలిక్యులేట్? Is there is any formula for this? So I already explained in class the synchronous speed formula, and how we can calculate the formula with a different number of poles. What is the formula for synchronous speed?
120 F by P RPM, sir.
120 F by P. So here the synchronous speed decides that how many poles are located in the rotor or stator. So ikkada enni stator poles unnayo daani base cheskoni speed anedi perugutu velutundi. So you can observe here the synchronous speed is inversely proportional to the number of poles. Suppose if your poles equals to 4, then what is the synchronous speed? The number of poles are 4.
Increases, sir.
I'm asking the value of ns. What is the value of ns if the poles are number of 4? Right, 1500. So how means the formula is 120 f divided by p, right? So here f is a frequency and p is a pulse. So 120 into 50 divided by 4. 4 ones are 4 is up. So 30 into 50 is 1500. So it means that the rotating magnetic field is rotating at the speed of 1500 rpm, but the rotor never rotates at 1500 rpm. So it is always rotating less than 1500 rpm. So that may be 1490 or 1480. So that's why the three-phase induction motor is called as asynchronous motor. So just remember that. So you may get in exam also. So which are the following motor we can call as asynchronous motor? DC motor, induction motor, synchronous motor. So different types. So in that induction motor we can call as asynchronous motor. Okay. Suppose if the rotor is rotating at synchronous speed, we can call it as a synchronous motor. Synchronous speed rotate అయితే దాన్ని synchronous motor అంటారు. Synchronous speed rotate కాకపోతే దాన్ని asynchronous motor అంటారు. So these are the three major points about that three-phase induction motor. Next, see here, it consists of two devices. One is stator and rotor. You may already know that why it is called as stator and why it is called as rotor. So it is no need to explain. Let me see that stator. So here, this is the way we are going to be structured and design the stator of an induction motor. So the outer, this is the outer face. This part is called as yoke, and it is also called as core. So and it is made up of silicon steel or cast iron based on our size of the device. And here these are the poles. So here there are multi number of this. So these are the slots are pole we can call as a poles, and we are placing the windings in the poles. It is copper winding. Okay, so this is the structure of this is the visibility of stator. Now we'll see that. So now you can hear us clearly now. Students, can you hear my voice clearly? So please reply. Then I will continue that. So just make sure your signal is perfect or not, because I'm connected the LAN wire, so there is no network problem here. Right. Now, so these are the three parts we can see in the stator: 1, 2, and 3. So the first one is outer frame. It is the outer body of the motor, and it protects that inner part of the machine. And stator core. So built up high grade silicon steel. సో జనరల్లీ లార్జ్ మిషన్స్ కి మనం ఎప్పుడు సిలికాన్ స్టీల్ యూజ్ చేస్తాం. సో ఎందుకంటే త్రీ ఫేస్ ఇండక్షన్ మోటార్ ఇప్పుడు కొంచెం పెద్ద సైజులో ఉంటుంది కాబట్టి వీఆర్ ఆల్వేస్ సపోజ్ టు యూజ్ దట్ సిలికాన్ స్టీల్, అండ్ ఇట్ క్యారీస్ దట్ ఆల్టర్నేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్. అండ్ నెక్స్ట్ వన్ ఈస్ స్టేటర్ వైండింగ్. It has the three phase windings, and the material we are using for the stator winding is copper. And these are the four parts it is belongs to the stator part. Now we see the rotor. So here the three phase induction motor is again classified into two types based on the rotor construction. So ఇక్కడ మనకు స్టేటర్ అనేది కామన్ గా ఉంటుంది. సో రోటర్ అనేది మనకు డిఫరెంట్ గా ఉంటుంది. సో బేస్డ్ ఆన్ ద అప్లికేషన్స్ అండ్ బేస్డ్ ఆన్ ద ఏరియా ఆఫ్ యూజింగ్. సో ఈ రోటర్ బేస్ చేసుకుని అగైన్ త్రీ ఫేస్ ఇండక్షన్ మోటార్ is classified into two types. One is squirrel cage induction motor, and next one is slip ring induction motor. So So these are the three types of three-phase induction motor based on the rotor construction. The first one is squirrel cage and second one is slip ring. Now let me see that how the squirrel cage induction motor rotor will be and how the slip ring induction motor rotor will be. So if you see that image, then you will get the clarity. So and these two having that different advantages and drawbacks. So let me discuss that. See here, these are the two types of rotor which are employed in the three-phase induction motor. The first one is squirrel cage and second one is slip ring. So it is also called as face wound motor rotor. Keep remember that squirrel cage induction motor antar ledam wound in face wound induction motor or slip ring induction motor. Okay. Now we'll see that one by one. The first one is squirrel cage induction motor. Right. Now it consists of a laminated cylindrical core. So laminated cylindrical core is having semi-closed circular slots at the outer periphery. So the meaning is it has the two cylindrical cores at the two ends. So and it having the semi-closed circular slots. So we have the different slots here. So 1, 2, 3. So ఈ విధంగా స్లాట్స్ ఉంటాయి అన్నమాట. అలాగే ఇక్కడ కూడా. And this slot should be connected by the copper or aluminum bars. So ఈ విధంగా కనెక్ట్ చేయండి. So these are connected in anti-parallel. Suppose ఇక్కడ చూస్తే 1, 2, 3 స్లాట్స్ ఉన్నాయి అనుకోండి. సో ఇక్కడ కండక్టర్ అనేది 2 కి కనెక్ట్ అవుతుంది, 2 అనేది 3 కి, 3 అనేది 1 కి కనెక్ట్ అవుతుంది. సో it is called as a anti-parallel connection. Okay. And what is the need of this type of connection means the purpose of this type of connection is to reduce that noise ని reduce చేయడానికి ఇటువంటి కనెక్షన్స్ అని ఇస్తాం. ఇక్కడ దీన్ని రోటర్ బార్స్ అంటారు. సో ఇక్కడ రోటర్ బార్స్ లో ఏ మెటీరియల్ యూజ్ చేస్తారంటే కాపర్ గానీ అల్యూమినియం గానీ యూజ్ చేస్తారు. సో ద కాపర్ ఆర్ అల్యూమినియం బార్ కండక్టర్స్ ఆర్ ప్లేస్డ్ ఇన్ దీస్ స్లాట్స్ and short circuited at each end by copper and aluminum rings called short circuited rings. So ఈ రెండు రింగ్స్ అంటే both ends లో మనం ఈ రింగ్స్ బేస్ చేసుకొని షార్ట్ సర్క్యూట్ చేస్తాం. So both ends closed by the short circuit. Now the rotor windings are permanently short circuited and it is not possible to add any external resistance. So ఈ విధంగా ఫిక్స్డ్ చేయబడుతుంది కాబట్టి we are not able to adding the resistance. So generally what is the need of resistance we need to add? ఎందుకు resistance ని యాడ్ చేయాలంటే the resistance is only purpose we are using in the motors is speed control. మోటార్ లో ఒక రెసిస్టెన్స్ ఎక్స్టర్నల్ రెసిస్టెన్స్ అంటే రియోస్టాట్ ని ఎందుకు యూజ్ చేస్తారంటే the only purpose is we have to be reduce them, we have to be control the speed. But here it is already closed path, then we can't able to add the external resistance. So that's why for squirrel cage induction motor we can't able to adjust the speed. అంటే మన స్పీడ్ ని ఉన్నట్టుండి పెంచడం కానీ ఉన్నట్టుండి తగ్గడం కానీ చేయలేం. That's why the squirrel cage induction motor is called as constant speed device, because in this squirrel cage induction motor we can't able to increase the speed or decrease the speed. It is keep on going to be rotating at constant speed. And this type of induction motor is not able to use where the speed is keep on going to be changing. Okay, suppose మీరు ఒక లిఫ్ట్ చూసారనుకోండి, లిఫ్ట్ కానీ ఎస్కలేటర్ కానీ, సపోజ్ లిఫ్ట్ కన్సిడర్ చేసుకుంటే ఒక లిఫ్ట్ లో ఒక పర్సన్ ఎక్కినప్పుడు సేమ్ స్పీడ్ లో వెళ్తుంది, 10 మంది ఎక్కినప్పుడు సేమ్ స్పీడ్ లో వెళ్తుంది. సో హియర్ వీఆర్ యూజింగ్ ద స్క్విరెల్ గేజ్ ఇండక్షన్ మోటార్. సో బేస్డ్ ఆన్ లోడ్ మన ఇంక్రీజ్ అయినా డిక్రీజ్ అయినా ఇట్ ఇస్ వోంట్ బాదర్ అబౌట్, ఇట్ ఈస్ గోయింగ్ టు బి రొటేటింగ్ కాన్స్టెంట్ స్పీడ్. అంటే మనకి ఎస్కలేటర్ కానీ లిఫ్ట్స్ కానీ ఇక్కడ యూజ్ చేసే మోటార్స్ అనేవి స్క్విరెల్ గేజ్ ఇండక్షన్ మోటార్ సంబంధించింది. ఓకేనా. స్లిప్ రింగ్ అనేది ఎక్కడ యూజ్ చేస్తారంటే ఎక్కడైతే మనకు స్పీడ్ అనేది వేరీ అవ్వాల్సి వస్తుందో, అంటే ఉన్నట్టుండి ఇంక్రీజ్ అవ్వడం కానీ డిక్రీజ్ అవ్వడం కానీ అలాంటి సందర్భాల్లో we can use that slip ring induction motor. Now I will show you that the diagram of squirrel cage induction motor. అంటే అది ఎలా ఉంటుందో ఇప్పుడు చూపిస్తాను. See the purpose of this అంటే squirrel cage induction motor చూడండి. Here the rotor slots are not parallel to the shaft, but it is skewed. Skewed ante చుట్టబడినని. ఇలాంటి కన్స్ట్రక్షన్ వల్ల అడ్వాంటేజ్ అంటే ఇట్ రెడ్యూస్ ద హమ్మింగ్ అంటే నాయిస్ రెడ్యూస్ చేస్తుంది, ప్రొవైడ్ స్మూతర్ టార్క్ ఫర్ డిఫరెంట్ పొజిషన్స్ ఆఫ్ రోటర్, reducing magnetic locking of stator and rotor. So these are the three advantages for the squirrel cage induction motor. Here the rotor parts are not in parallel. So due to this reason we can achieve these three advantages. Right. So this is the structure of squirrel cage induction motor. See here, this is the shaft and this is the two ended rings. So this end and this end. Out of these two ended rings, we have the slots. So it is slot 1, slot 2, 3, 4, 5, 6 like that. Now here it is 3, 4. So it is 2 like that. So it is connected to anti-parallel. అంటే 1 నుంచి 1 కనెక్ట్ చేస్తే దాన్ని parallel అంటాము. 1 నుంచి 2 కి 2 నుంచి, so this is the anti-parallel. Suppose if it is like this means you can say it is parallel. If it is like this means it is called as anti-parallel. So here we can, this is the ended rings are iron bars and these are called as rotor bars. So this is an important question. What type of material we are using in the rotor bars of a squirrel cage induction motor? Aluminum or copper. Okay, now so this is the visible structure of a squirrel cage induction motor, and the purpose of this anti-parallel rotor bars is used to reduce the humming sound. Second one is providing the smooth operation. Third one is reducing the magnetic locking. Okay, so these are the three advantages in squirrel cage induction motor. Now let me see that second one, that is slip ring induction motor. Right. So this is the structure which is using in the real-time application. So you can observe here, no bar should be connected to the same slot. So 1 నుంచి 2 కి, 2 నుంచి 3 కి connect అయ్యాని 1 1 ఆ విధంగా కనెక్ట్ చేయాలి. So this type of connection we can call as anti-parallel or not parallel structure. So this is the visibility, and what we called these holes, ఈ holes ని ఏమంటారు, and what is the purpose of these holes? See, మీకు ఆల్రెడీ చెప్పాను, rotor లో we are providing that right. So it is used to the cooling purpose, and it is called as air ducts. DUCKTS. So the holes which are providing on the rotor, we are call it as a air ducts, and the purpose is for the cooling. Okay, now are you got clear on the squirrel cage? So how it will be structured? Now you see that face wound rotor, and it is also called as slip ring rotor. See here, the slip ring rotor is all the rotor winding always connected in the star connection. Here RYB, the both all ends of this three phase we are connected to the external rheostat, that is RYB. So these are the external rheostats, and these are connected to the slip rings. So these are the slip rings 1 2 3. So we have 3 slip rings, and these 3 slip rings are connected through the external resistance, and the make contact between the slip ring and rheostat we can call as brush. So ఒక స్లిప్ రింగ్ కి ఒక కాంటాక్ట్ మనం చేయాలంటే మనం డైరెక్ట్ గా కాంటాక్ట్ చేయలేం. So we are using the brushes, then the contact should be happen between the slip ring and the external rheostat. So this is the structure of the rotor of a slip ring induction motor. So here the rotor is always providing in the star connection. At the end of the star connection we are going to be connect the slip rings, and out another end we are going to be connect the external rheostat, and the purpose of this external rheostat is we can adjust that rotor speed. So meeku question adagachu, which type of motor we can control the speed from the rotor side, ante ఏ మోటార్ కు మన రోటర్ సైడ్ నుంచి స్పీడ్ ని కంట్రోల్ చేయొచ్చు. The example is slip ring induction motor. Slip ring induction motor లో మన రోటర్ సైడ్ నుంచి కూడా ఈ విధంగా మన స్పీడ్ ని కంట్రోల్ చేయొచ్చు. ఓకే, సో దట్ ఈస్ ద అడ్వాంటేజెస్ ఆఫ్ స్లిప్ రింగ్ ఇండక్షన్ మోటార్. కానీ ఇటువంటి అరేంజ్మెంట్ మనం స్క్విరెల్ గేజ్ ఇండక్షన్ మోటార్ లో మనం ప్రొవైడ్ చేయలేం. సో దట్స్ వై ద స్క్విరెల్ గేజ్ ఇండక్షన్ మోటార్ ఇస్ లిమిటెడ్ టు దట్ కాన్స్టెంట్ స్పీడ్ applications, but slip ring induction motor we can use that variable speed applications. అంటే కొన్ని అప్లికేషన్స్ కి స్పీడ్ ఎక్కువ కావాలి, కొన్ని అప్లికేషన్ స్పీడ్ తక్కువ కావాలి. అలాంటి సందర్భాల్లో మన స్లిప్ రింగ్ ఇండక్షన్ మోటార్ అని ప్రిఫర్ చేయొచ్చు అన్నమాట. Right. Now we'll see that what are the how we can what is about slip ring induction motor. So the first one is it consists of laminated core having semi-closed rod outer periphery and carries that three-phase insulated winding. So this is the rotor side. So we have the three-phase winding, right? It is connected in the star, and the rotor is wound for the same number of poles as that of rotor. Ante stator lo enni poles untayo rotor lo kuda same poles untayi. So ఇది కూడా one of the important point. So we are placing that the same poles is stator and rotor. The three finished terminals are connected together forming a star point, and the three star terminals are connected through the slip rings fixed to the shaft. So మనకి ఇక్కడ చూస్తే one of the end it is connected to the star and one end is connected to the, so this is the shaft here and it is slip rings. So we are connected to slip rings here. Right. So this is the structure of slip ring induction, that is squirrel slip ring induction motor. So if you observe that three slip rings, that is 1, 2, 3. Now if you want to adjust the this rotor speed in different waveform, different variables, at that time we had to use the slip ring. So ఇక్కడ ఎలా ఉంటుందంటే, and it is in this point we are going to be connect one brush. We are placing three brushes. With the three brushes we are going to use that three resistor. One other end of three resistor will be short circuited. If we want to control the speed, we can use this combination. Okay na? So ఇక్కడ రెసిస్టెన్స్ అనేది చేంజ్ చేస్తా ఉండడం వల్ల మనం స్పీడ్ కంట్రోల్ చేయొచ్చు. And this is only possible in the slip ring induction motor, and this is the structure and this is the visibility of slip ring induction motor we are using in the three-phase motors. Right. Now we'll see that what is the principle of operation in three-phase induction motor. So here a rotating field is set up in the stator, that is rotating magnetic field, and this rotating magnetic field was produced by the three-phase supply. Now the stationary rotor should be cuts the revolving field, and due to the electromagnetic induction and induced in the rotor. Now as the rotor conductors are short circuited, then current flows through them. It becomes a current carrying conductor in magnetic field. So this is the same principle what we discussed in the DC motor. So ela ante when we are applying the supply to the stator will produce the field, and this field will be cut by the rotor conductors and EMF will be induced. Due to this EMF, the current will flow to the conductors, then it will be rotating. So this is the principle in the motor, and it is very similar. Now the additional term which is involving in the induction motor is slip. Why? Because general ga manaku motor anedi synchronous speed rotate avvali, but it is slips to that rotor speed. Ante ee synchronous speed anedi slip avutundi, ante reduce avutundi. So ikkada reduce anachu man. So we can call it as a reduction of speed. Now what is the involvement of slip in the induction motor? So let me see that. See here, induction motor rotor always rotate at the speed less than the synchronous speed. Okay na? The difference between the flux and rotor speed we can call as slip. So this is the formula for slip. So percentage slip is synchronous speed minus rotor speed divided by rotor speed. So we can get that how much of slip is happened. So generally the slip is for that induction motor is always lies between 0.02 and 1. So 0 కి 1 కి మధ్యలో ఉంటుంది, అంటే 0.1 గానీ 0.2 గానీ 0.3 గానీ. ఓకేనా? సో ఎప్పుడు స్లిప్ అనేది 1 అవుతుంది, ఎప్పుడు స్లిప్ అనేది 1 0 అవుతుంది. when it is slip 1 means slip is equal to 1 means at starting condition. ఓకేనా? ఆ స్టార్టింగ్ కండిషన్స్ లో స్లిప్ అనేది 1 అవుతుంది. Why? Because at that condition there is no rotor speed, nr equals to 0. So ఇప్పుడు చూడండి, nr equals to 0 substitute, the slip is equals to ns and it is equals to 1. Okay, so its formula is ns minus nr divided by ns. Okay, ఎప్పుడైతే nr అనేది 0 అవుతుందో ns by ns ఏమవుతుంది 1 అవుతుంది. సో దిస్ ఇస్ ద స్టార్టింగ్ కండిషన్. ఎప్పుడైతే రోటర్ అనేది రొటేట్ అవుతుందో then it gains some value. At that time the slip will be varies between the 0 to 1, and the slip speed s into ns we can call it as a slip speed, and its formula is ns minus nr. అంటే 1500 rpm నుంచి 1490 గనక సబ్ట్రాక్ట్ చేస్తే then 10. సో here 10 is a slip speed, అంటే సింక్రనస్ స్పీడ్ కి రోటర్ స్పీడ్ కి ఎంత స్పీడ్ స్లిప్ అయింది అనేది this is denoted by this formula. సో మీరు ఇక్కడ యూనిట్ లో ఇనిషియల్ గా మీరు గుర్తుపెట్టుకోవాల్సిన ఫార్ములా అంటే ns ఫార్ములా, దట్ ఈస్ 120 f by p. This is the primary formula, and second one is slip. Slip is equals to ns minus nr divided by ns. If you want to represent in terms of percentage, you can multiply this divide by both sides by 100. So this is the second formula, and ns into s is equals to ns minus nr. This is synchronous speed formula, slip formula, slip speed formula. So these are the three initial formulas we have to be remember in this unit. Right. So this is the cross-sectional view of three-phase induction motor, and this is the squirrel cage induction motor. So because it doesn't have any slip rings, so only it has the bearings. So this is about construction and slip of three-phase induction motor. In tomorrow class we are going to discuss how the slip will be affects the rotor parameters. Okay na, మనకు ఈ ఆపరేషన్ అనేది దేనిపైన డిపెండ్ అంటే రోటర్ పైన డిపెండ్ అయ్యారు. అంటే రోటర్ ఎలా రొటేట్ అవుతుంది, ఆ రోటర్ తక్కువ రొటేట్ అవడానికి రీజన్ ఏంది, ఎక్కువ రొటేట్ రీజన్ ఏంది, సో ఇవన్నీ ఏమంటాం. ఈ రోటర్ పారామీటర్స్ పైన స్లిప్ అనేది ఎలా ఇన్వాల్వ్ అవుతుంది అనేది నెక్స్ట్ క్లాస్ లో మనం చూసుకుందాం. సో ఓకే స్టూడెంట్స్, దిస్ ఇస్ అబౌట్ టుడేస్ క్లాస్. ఐఎమ్ గోయింగ్ టు ఎండ్ దిస్ క్లాస్ నౌ. థ్యాంక్ యూ.